Good afternoon, students. Now we come to, after the linear concurrence modulo prime power, we come to arithmetic function. Okay. So by arithmetic function, an arithmetic function is a function whose domain is the set of natural numbers. Okay, so here any function whose domain is a set of natural number, and by natural number we said the collection of set 1, 2, 3 and so on is called a natural number. So any function whose domain is this set of natural number is called an arithmetic function. So in this chapter we are going to study four such arithmetic function, and we call them as tau of n, which is called the number of divisors function. Next is sigma n, which is the sum of divisor function, and then mu n, which is the Mobius function. All this they have domain as a set of natural number, Mobius function, and phi n, the Euler's function. So all these are important arithmetic functions that we are going to discuss. And they have domain as n, the set of natural numbers. So to start with this, we begin with the definition of summation function. So if you have fn and gn be two functions defined on n, means having n as a set of natural number, domain n as a set of natural number, then we say that gn is the summation of here this gn is called the summation function of fn if gn is the sum or the summation of all fd as d runs through the divisors of n. And symbolically we write here gn is equal to summation of f of d, where d runs over the divisor of n. So if you have two functions fn and gn's defined on the set of natural number, then this gn is called the summation function of this function fn if gn is the summation of all fd's, where d here stands for the divisors of n. For example, and symbolically we write gn is called summation of fd, where d runs over the divisor of n. So for example, if you have n is equal to 6, and what are the divisors of 6? Divisors of 6 are 1, 2, 3 and 6. So what will be g of 6? According to definition, it is summation of f of d, where d runs over the divisor of 6. So what are the divisors of 6? What is d here? D is 1, 2, 3 and 6. And summation stands for the sum of all those divisors. So we can write it as f of 1 plus f of 2 plus f of 3 plus f of 6. I hope it is clear to you. So this is an example of summation function. The next definition we come is summation sum of divisors function. So here we denote sigma and denote the sum of the divisors of n. And symbolically, or we can use this notation, sigma n stands for the sum of all the divisors of n. So for example, if you have n here is equal to 6, the divisors of 6 are 1, 2, 3 and 6. And by sigma n here we define it as the sum of all these divisors, that is what the divisors of 6. So for n is equal to 6, what is sigma 6? It stands for summation of d, where d runs over the divisor of 6, where d stands for the divisor of 6. And what are the divisors of 6 here? They are 1 plus 2 plus 3 plus 6, which is equal to 12. So if you have n is equal to say 9. What are the divisors of 9? They are 1, 3 and 9 itself. So therefore, what is sigma of 9? Sigma of 9 here will be the sum of all these divisors. So here this stands for the divisors of 9. So here you have 1 plus 3 plus 9, 9 plus 12, 9 plus 3 is 12, 12 plus 1 is 13. So sigma 9 gives you 1. So if P is a prime, prime number and K here is greater than or equal to 1, then what are the divisors of P to the power K? Then divisors of P to the power K are 1. 1 always divide P to the power K. P to the power 1, P square, P cubed, dash dash and P to the power K. These are all divisors of P to the power K. So that we have sigma of P to the power K. By definition, it stands for summation of D, where D runs over the divisor of P to the power K. That is the sum of all these divisors of P to the power K. That is 1 plus P square plus dash dash plus P to the power K. And the formula for this is P to the power K plus 1 minus 1 divided by P minus 1. So next we come to the main part of this topic, that is arithmetic function. We are going to define the number of, that is tau of n, the number of divisors function. So tau n here denotes the number of divisors function, and we use the notation here for tau n. It stands for summation of 1, where d runs over the divisor of n. This notation means that to compute, here this notation means to compute tau of n. To compute this tau of n, we add a 1 for every divisors of n. I think it is not clear to you. So what is tau n? Tau n stands for the number of divisors function, and to compute this value tau n, we add 1 for each divisors of n. For example, if you have n is equal to 6, the divisors of 6 are 1, 2, 3 and 6. And what is tau of 6 here? We add 1 for every divisor. So here summation of 1, where d runs over the divisors of 6. So we add 1 for this divisor 1, and then add 1 for this divisor 2. So 1 plus 1 plus 1, which is equal to 4. So tau of 6 gives you 4. So therefore by tau n, we means that the number of divisors of 6 is equal to 4 by adding 1 to each or to every divisors of 6. Another example, we can take tau of 4. What are the divisors of 4? 1, 2 and 4 itself. So 1, where d runs over the divisor of 4. So the divisors of 6 are 1, 2 and 4. So we add 1 to each or to every divisor. So 1 plus 1 plus 1, which is equal to 3, in order to obtain the value of tau n, that is the number of divisors function tau n. So I'll stop here for